All right, folks, let's do number 57. A person goes for a walk, follows the path in this figure. I'm not going to draw. I'm just going to use this picture. So the total trip consists of 4 straight lines, paths. At the end of the walk, what is the person's resulting displacement? So the displacement from here to here, folks. So that's what they want. So we're going to calculate what this is. And in order to do that, we're just going to add the vector as a component. So I'm going to write this as the displacement of this particular vector that we're looking for. It's going to be x in the I hat direction plus y in the j hat direction. Now we're going to look what the, and I'm treating these as variables, unique solutions that we're going to need. So x, it really doesn't matter anyway. So x is going to be 100 meters. Because we can see that this goes 100 meters in that direction, minus 155 cosine of 30 degrees. 150 cosine of 30 degrees. And so many vectors? There's 4 vectors, and we just added 2 of them that has horizontal components. So that's going to be done right there. So that's going to be our x. So this is going to be our x. And now we're going to look for our y. So the y is going to be, oh, I got mixed up. Okay. So we're going to start as minus 300 newtons. Why do I keep saying newton? Meters. Oh my God. So, so minus that, added to, or minus that, because it's pointing downward, 150 meters, sine of 30 degrees. This is why it's good to slow down, guys, but it's kind of hard to do these videos at the same time, though. Or at least for me, it is. Anyway, so add it to 60 degrees. And I don't think I added the other component, did I? Oh, no, I didn't. That's okay. So this is going to be minus that component, 200 cosine of 60 degrees. So that's going to be minus in that direction. So minus 200 meters cosine of 60 degrees. All right, so, and then this one, plus 200 meters sine of 60 degrees. And then let's just quickly confirm this. So you have going to the right, going down, going downward, but it's going to change 150 cosine, and then it's going to take minus the extra 200 of that. So that's correct. The one is going to be negative down, down. That's both a negative, and then it's going to go right up to 200 meters. All right. So those are your components. So once you compute this, the result should be negative x being negative. Whoa, I didn't store this. There we go. So x is going to be negative 120 or 130 newtons. I'm just going to round it there. Meters. Cos in the I hat direction. Minus on this component right here, y being (201) newtons. So we're gonna get the, those are the components. We're gonna get the angle. So the angle is gonna be both of those guys are negative, so we're going to take tan inverse of that, add it to 180. So you should get 237.2 degrees. That's the angle. And the magnitude of those, I'm presuming you already know your vectors. the magnitude of this, the magnitude of that is going to be 240 meters. At the angle above the horizontal net. So, all right, folks. Let me double confirm this real quick. Yeah, that looks correct. So anyways, folks, those are the answers. So 240 meters.